Hello, my name is Deb Nolan. I'm the Associate Dean for Computing, Data Science, and Society at the University of California, Berkeley. And today I'd like to talk to you about the data science major at Berkeley. To begin, I'd like to give you a little background. We have 30,000 undergraduates at Berkeley, and 22,000 of them, or about 3/4, are in the College of Letters and Science. Our students have a very strong ethic in public service, and each year over 5,000 students do off-campus public service. In addition, 30% of our students are Pell Grant eligible, and 20% are first-generation students. Also, 20% of our students are community college transfers. About 5 years ago, there was an alignment of interest in data science education coming from all across campus. The chancellor appointed a rapid action task force and charged them with coming up with a plan for giving all freshmen a data experience. The committee consisted of faculty from across campus, and they came up with a recommendation for a whole new suite of courses that would engage all undergraduates with data. At the same time, the D-Lab had been created, and it was supporting data-intensive social science research for faculty and graduate students. The statistics department was undergoing an academic program review, and the final report had many strong recommendations for statistics getting more involved in data science. And in computer science, their introductory programming class was exploding, with more than 1,800 students enrolling in the course every semester. In less than 1 year, our first course, Foundations in Data Science, launched. This course had no mathematics, statistics, or computer science prerequisites aside from high school algebra. The students were doing all of their computational work in the cloud using Data Hub. So it didn't matter what kind of computing equipment the students had, as long as they had access to a browser. They could do their work for the course. The basics in inference are taught in our Data 8 class via simulation and Bootstrap, and the students learn about computation through Python and a specially crafted library called Data Science. One unique aspect of our introductory data science program were the connector courses. Faculty from all across campus were teaching seminar courses simultaneously or immediately after the Data 8 course, where students would learn about the data-centric questions in the faculty members field. You can see some examples of these here on this slide. There are connectors in children in the developing world, immunotherapy of cancer, data science in the mind, linear algebra, cognitive neuroscience, etc. These have proved really popular among the undergraduate students, and at the same time, they've been a springboard for our faculty to then develop data science courses in their own disciplines. 2 years after the launch of Data 8, we introduced a new course called Principles and Techniques of Data Science. This is an upper division course and has more of a technical aspect to it. Like Data 8, it also integrates the inferential thinking with the computational thinking. Students gain practice in the full data lifecycle in this course, and they learn a lot of data technologies for accessing, cleaning, analyzing, and computing with data. And at the same time, they learn about data design and generalizability. We approach the statistical pieces of the course through the notion of empirical risk minimization. And we also have a component of what are the implications for large data? And those implications could be both computational as well as inferential. Throughout the course, we revisit the full data life cycle several times over as students work on projects and get experience working with data and answering questions. There are 3 types of prerequisites for Data 100. There's the original Data 8, the Foundations of Data Science. And in addition, there are 3 courses in mathematics, 2 semesters of calculus, and 1 semester of linear algebra. Plus, an additional course in program structures. Both Data 8 and Data 100 started with 100 students in the class, but their enrollments have rapidly grown. In the most recent semester of spring 2020, 1,350 students were enrolled in Data 8 and 1,100 were enrolled in Data 100. And this summer, the enrollments for both of our courses exceeds 400. Now that you have a little bit of background about Berkeley and the creation of Data 8 and Data 100, I'd like to give you some information about the data science major itself. Once we had Data 8 and Data 100 successfully launched, we were ready to create the data science major. This diagram shows the mapping of the major with the various types of courses. The first row consists of the lower division or introductory courses. That includes Data 8, the foundations of data science, as well as the mathematics courses and the computing course, the prerequisites for Data 100 that we just spoke about. Then comes Data 100, which is the bridge between the lower division and the upper division. In addition to Data 100, the students then go on to take more technical courses. These include a course in probability and 2 courses in computational and inferential depth. These could be statistics courses or computing courses or other technical courses. The capstone of the technical courses is modeling, learning, and decision-making. 2 aspects of the data science major which are unique, and I'd like to spend a little bit more time talking about, is the domain emphasis and the human context and ethics. Every data science major must take 3 courses in a particular domain. Each domain consists of a collection of courses around a data-intensive research field or an integrated intellectual thread. The 3 courses can consist of 1 lower division and 2 upper division courses, or 3 upper division courses. We offer 25 different domains for the students to choose from. Some possibilities are laid out on this slide, and you can see they range from human biology and computational biology to inequalities in society, social policy and the law, quantitative social sciences, robotics. The sheer choice is truly amazing. The main purpose of this domain is for a student to have some area of expertise in which data science is applied. In addition to the domain emphasis and the technical courses, another important piece of our data science major is the human context and ethics. The human context and ethics themes are integrated throughout both Data 8 and Data 100. And in addition, we have one dedicated course that all students must take in human context and ethics. This course addresses the human and social structures and practices that shape data science activity. We do have more than one flavor of this course. They are taught by faculty in philosophy, information, law, business, and history. So stepping back, we see our major as consisting of 4 basic pieces: computational thinking, inferential or statistical thinking, an area of expertise, a context area in the domain emphasis, and the human context and ethics portion. So what's next for us? We plan to continue to develop and grow the Modeling, Learning, and Decision-Making course. It started this year with enrollments of 100 and will go to enrollments of 250 in the fall, and we imagine it growing quickly, just like Data 8 and Data 100 did. In addition, as we scale our classes, we really want to be thinking hard about sound pedagogy for such large classes. And a new topic that we're just taking up is to relook at the mathematics prerequisites for the major and think about coming up with new courses that are specifically designed for data science majors. So we're in conversation with the mathematics department about a math for data science class. That sums up a description of the data science major. Now I'd like to take a minute or 2 to tell you a little bit about the data science minor. The data science minor was launched in spring of 2020, and it features 2 pathways to serve students with different interests and backgrounds. It consists of both lower division and upper division courses. In the lower division, again, we have Data 8 as a requirement, as well as basic programming skills, and a lower division introduction to probability. As for the upper division, we have a core data science course or courses. I'll speak about them in a minute. Again, we have a course in human context and ethics as part of our minor, and then 1 to 2 electives. One of our pathways has 1 data science core course, and that's Data 100. So this is a more technical option. As you've seen already, it requires 2 semesters of calculus and a semester of linear algebra. On the other hand, for students who want a gentler introduction to data science, we have a 2-course option for learning about data science, and that's where we split the data technologies from the modern statistical methods. Both of them still integrate inference with computing, but over a 2 semesters of coursework. In this option, we only require 1 semester of calculus, and this option is taught using the R programming language, whereas the 1-course core option is taught using Python. Thank you very much for listening to my talk. Feel free to reach out to me at any point with any additional questions that you might have about the data science major and the data science minor.